Hi everyone! This is my walkthrough on how I made dynamic music similar to old platformers like Banjo-Kazooie. Now this video is going to be pretty long, so if you want to skip to a specific part, there should be a link in the description that'll show you where to go. In the good old days of Nintendo 64 platformers, composers would use MIDI files to play back music. Because other music file formats like WAVs or MP3s are much larger than MIDI files. There simply wasn't enough space in the game cartridge to store all of that musical data without compressing it beyond recognition. One of the cool things that MIDI files allowed was dynamic changes in tempo and instrument selection that happened right in the game. Notice how the tempo and instruments in the music track change, but the same melody is still being played. The melody also doesn't restart itself every time the music changes. This is all possible with programmatic changes to MIDI files, which can be changed within the game's engine, because it's all just data. In today's age of game audio, MIDI is rarely used. If your game has very high quality orchestral music, for example, you're going to need to use WAV files for it to sound right. However, using Wwise, I've come up with a way to mimic this old technique of dynamic music without using MIDI. It has its drawbacks for sure, but in general I think it adds a great amount of depth to the dynamic music scheme of a game. So, how does it work? Well, first we need a melody. So here's a really basic form of the melody I picked. It's a very Grant Kirkhope-y. It sounds like it could be ripped straight from Banjo-Kazooie. So I have 3 different versions of this song. I have a version for sort of the normal level. It's daytime, you're just running around, so it's nice and bright, bouncy, and peppy. Then I have a version when you're in a cave. So it's got a slower tempo and sort of more silly sounding instruments, I guess you could say. And then the last version I have is a version where it's nighttime. So this one's really slow. It's slow strings playing, and there's a harp and celeste. So let's see how it works in game. Okay, so we start off hearing our main track. It's daytime, we're walking around, everything's great. And our loop is right there, so it's a pretty short track. So now we're gonna go into my cave. So you'll notice the music changed, but the melody is still in the same part. So it's like the music changed its tempo and it changed its instruments, but it's still the same music track playing. Right where we left off, outside, everything's great, this guy's running around. Right back into the cave. Alright, and we hit this button and it'll turn to night. So now we have our slow melody. And we're back in the cave, and the tempo goes back up, back to our cave instruments, and we're back at our regular tempo. And now we're outside again, but it's nighttime, so it changes to the nighttime music. And daytime again. And you can actually do this as fast as you can, and it will never choke up or get lost. And so you see, you sort of have to fully commit to the cave to get the cave song. So you can think of it as it's just one music track playing, right? And the only thing that's really changing is the tempo and the instruments you're hearing. So how did I do it? Well, the answer is actually pretty simple. Think, if we're going to change the speed of a WAV file, what do? We change the sample rate. Now, the one downside with changing the sample rate in a file is it also causes the pitch to change, so it'll end up sounding really weird. So we actually don't want to play music like that because it'll sound really weird and distorted. However, every time you're changing the sample rate of music, you're technically giving it a new tempo. So if we can determine what this tempo is and say, write another piece of music that's the same exact tempo, they'll line up perfectly. So if we take our original track that's 120 beat per minute and halve the playback speed, it will effectively play back at 60 BPM. To really show how this works, I'm going to take my 60 BPM track that I wrote with my 120 BPM track that's slowed down. And if you actually go in and look at the files, they are the exact same amount of samples, which means they are the exact same length. So using this knowledge, you can make any number of music tracks the same length by properly resampling them. So there may be some people wondering, why do we have to make them all the same length? And I'll show you using a traditional model of dynamic music that's really popular in games right now. And that's where you just have a bunch of looping tracks that are playing simultaneously, and you crossfade between them when you enter a new room. And don't get me wrong here, this is a perfectly acceptable way of doing interactive music. The thing with this though is that it sounds like there's multiple songs playing and that you're just switching between them, because that's literally what's happening. This method is sometimes referred to as vertical reorchestration. With the implementation that I'm using, it feels more like one single level song, and it's simply changing tempo, or the instruments playing. Heck, you could get real creative and change the notes from a major key to a minor key. Okay, so here we are in Wwise. So I already have this project set up, and I'm just going to walk through sort of what's happening here. So first off, I have my 3 different music tracks, and they're all imported here. So let's go to this one first. So this is just imported as a music segment, or whatever it's called. And as you can see, well, if we go here actually, I have my tempo set to 120 and 4/4 because that's what my music's at. When I go in here, I want to make sure that my exit cue is set to the end of the track. So when it loops, you get that tail there, so it's a perfect loop. And I don't believe there's anything else here. And then I put this into a sequence container, or I put this into my sequence container, and then I make sure it's set to infinite loop. So whenever I play this event, or I create a play event for this container, it will just loop this track infinitely. So that's pretty straightforward. If you've ever done any sort of music implementation in Wwise, this should be very familiar to you. Alright, so now, on to the cool stuff. So I need to create an RTPC for each of these, for 60, 90, and 120. So I created an RTPC, and it's called track speed. And what you'll see is that when track speed for my 120 beat per minute, because that's my fastest track, when track speed is set to 100, or its maximum value, this has a playback speed of 1, which means that this will play back at its normal tempo. So actually, if I play this, So it just plays back normally. Cool. All right. And then if I have track speed set to 50, if I go here, actually highlight this. So when it's set to 50, it will play back at 0.75, but we also won't be able to hear it because we don't want to hear it. And actually, you'll get sort of a cool visual of what's happening if I play it. Well, you won't hear it. So I play it. So you won't actually hear any of this in the game. It all happens instantly. This transition from here to here. So why 0.75? So this is when the 90 BPM music will be playing. Right, this track. And so in order to make sure that the two tracks are lined up, when this value is 50, we have to play back this track at 0.75. So why 0.75? So Wise's resampling function, if you set it to 1, that means it's unaffected. So that will be just normal playback speed. The lower you set it, the slower it gets. So we can do a little bit of math and find a proportion that will set it to the right value. So if we have our 90 beat per minute music and 120 beat per minute music, the 120 beat per minute music needs to play back at 90 divided by 120 for 120 to match up. So if you do 90 divided by 120, you get 0.75. And that's where that goes. And if we jump in here, the same is true for this one, but the other way around. So when our 120 beat per minute music is playing, our playback speed needs to be set to 1.333. And technically it's infinite 3. And because this is an imprecise number, it will get off. But I believe if you do the math, it takes 7 hours of continuous playback of this one track for it to get off by about a second. And even then, that's still not very noticeable because you're just doing transitions between them. So that's something that you can mitigate by picking tempo numbers that are perfectly divisible by each other without having to use fractions. But this isn't a bad solution. It still absolutely works. So we have track speed set to 50 here, and that's set to 1 because we want it to be its normal playback speed. And obviously we want this to be set to 0 so that we can hear it. And then same thing, so when track speed is set to 0, this should play back at 60 divided by 90, or am I thinking about the other way around? 90 divided by 60. One of those two. I always forget which is which, but that's 0.666, and I have it rounded up. And same thing true for this one. So we do the multiplication again. This will be playing back at 1.5 for 90, and it will be playing back at 2 for 120, because 60 times 2 is 120. It's actually pretty simple once you think about it. You can do this for any number of music tracks at any tempo technically, though you won't always get such a nice number. Okay, so now we have all of this set up and we need to create our events. So it's a little bit more than just doing play for an event. So let's go to the designer and go to our events. So I have 4 events you'll see here. And this is the first one that we need to play. So this is play music. And what this is going to do is it's going to set our track speed to, you set that to whatever value you need for your initial music track. So for our game, we start off by playing the 120 beat per minute one. So I have it set to default to 100. And this is actually something that you can set in game syncs as well. Track speed. So I have, oh no, this should be 100 actually. All right. And this is just sort of like a fail-safe thing. Oh, and I have these all set to global changes because music is usually not confined to a single game object. I mean, it can be, but because there's usually only one sort of global music object, I just have it set to global. And then I also reset the voice volume of everything just in case there's any modifications that have been made at any point. You always have to reset the... And this is the voice volume, so this is this thing, not necessarily this thing. They're actually two separate things. All right, and then you'll see we have a play event for music 120, play event for music 60, and for 90. Just put this here. And so you'll notice here that there's a delay of 0.1. And this is just something that I've found that it's like a weird quirk of Wwise. I'm not sure if it's like a bug or whatever, but if you play a music track and then any music track you play after it will be, I guess this has a 0.1 second delay, the first one does. So if I get rid of this delay, they actually won't line up. So for each music track after the first one, you have to delay it by 0.1 seconds so that they actually line up. And it's just a quirk of Wwise, I guess. Anyway, it's pretty easy to get around. You can just set these numbers here. So then we have our different events. So we have play music, and music 120 is going to be playing as per usual. Now let's say we want to go into the cave. So that's going to trigger the play cave event. And so what happens is that we set both of our music tracks that aren't play cave. They need to be set to the lowest volume possible. And I have this set to, it'll take 0.75 seconds for the volume to go down. So it doesn't instantly turn off. It like fades out over 0.75 seconds. And same thing for this one. And you'll notice that even though our music 60 isn't playing, you still have to have this in case, say, it's nighttime and we go into the cave. So this makes it so that we can transition from any state to any other state, not just, daytime to cave. So we'll set our track speed parameter to 50 because that's the value of the one in the middle, the 90 BPM cave song. And then we fade in our cave music. It's also important here that you delay this by however long it takes for this to fade out, because you don't want this music fading in while this one's fading out, because it will sound really weird, because it will be all distorted and it'll be playing back at the wrong sample rate. It'll just sound super weird. So that's sort of one of the unfortunate downsides to this method, is that you can't technically crossfade the music because all the tracks have to be playing at the same exact time, and they have to be resampled so that they're playing simultaneously at the same spot in the music. So then same thing for night. We mute our other tracks, 0.75 seconds. We set our track speed to 0. And we fade in our music track. So, if you could follow along with anything I just said, that's how to do it. And the cool thing is that I have 3 here, 3 different music tracks. You can technically do this with any number of music tracks. You just have to have, it takes a lot of manual work putting them all in and setting them all to the right thing, but you can do it with any number of music tracks so long as they're composed and rendered properly. So it's actually a lot easier than you would think it would be. All that you need to do really is make sure that all the music tracks you write are the same amount of bars in length. Now, while this is a very cool technique, as with everything, it has its downsides. So probably the biggest downside to this technique is that you can't have the music crossfade between tracks. Because of how it's set up, there has to be a moment of silence somewhere. Even if it's incredibly short, there must be a moment of silence during a transition between 2 different tempo tracks. That's simply because the tracks are resampling themselves so that they're always lining up with each other. So if two are ever playing simultaneously, you're going to hear one that sounds really weird and distorted. And that's just something, so you have to have the first one fade to 0 in some amount of time and then have the other one fade up. It could happen instantly, or it could be a fade. But that is the number one downside, is that you have to have this fade in there. If you could find a solution to this somehow, I'd be great to hear it, but as far as I know, there's no way to mitigate this. There are a couple ways I think you could mask it, so you could put a cymbal swell or a harp gliss or any kind of sound effect to sort of mask this transition, but it will still have to be there. So number 2, it takes slightly more resources, technically. So all of the music tracks have to be playing simultaneously, even if you can't hear, or even if you can only hear one at a time. So that uses slightly more system resources because it has to, technically it's still playing all of these simultaneously. Though that's something that's still an issue with vertical reorchestration techniques. So this doesn't really introduce a new problem as far as that's concerned. However, another thing with it is that all of the looping tracks have to be the same length if they're going to line up with each other. So for example, if you make one of your looping tracks, like your cave music, shorter, then it won't line up anymore. It will just be a normal vertical reorchestration. There won't be any uniqueness to it anymore. So if your longest track is 100 measures long, then they all have to be 100 measures long. And if that first track is 2 minutes long, then the slow one has to be 4 minutes. And this could cost you extra resources, such as memory or disk space. So you sort of have to grapple that with what you want. Though, to be fair, it's not that much more, and most modern systems should have no problem running it, but it is technically another risk, I guess, that needs to be mitigated. And then the last one, it's sort of common sense, I guess, and it's not that much of a downside, but it takes longer to set up. Simply setting this up in your project, writing all the music so that it's perfectly written to spec, it's going to take a little bit longer than just writing a single music track or writing all of your level music and just crossfading between it very simply. Though, as with most things, when you put more time into it, it usually ends up sounding better in the end. So I think it's worth it personally, but that's, again, something that you have to consider. So hopefully you came away with some new knowledge from this video. If you thought this was cool, go ahead and let me know. I'd love to hear from everyone. And if you know of any other games that are using a technique similar to this, I'd love to see them. This is something that I think is really cool, and it's something I've always wanted to do in a game personally. Interactive music schemes, I think, are just a really cool topic. So thanks for watching, and I'll see you guys later.